Hello everyone. In this video, I will explain the concept of deletion in AVL trees. In the deletion process, we have mainly two types of rotations. The first one is L rotation and the second one is R rotation. The L rotation is also called as left rotations. We have three different cases in the L rotations. Those are L1 rotation, L-1 rotation, L0 rotation. And in the R rotation, again we have three different cases. Those are R1 rotation, R-1 rotation, R0 rotation. These rotations are not new. We have already seen these rotations in the AVL insertions and we will see these with examples. The first rotation is L rotation. We delete the element at the right subtree, so the tree becomes heavy on the left side. That's why L imbalance occurred. Based on the imbalance type, I am giving that rotation name as L here. To imbalance this tree, suitable rotations are applied to balance the tree. And the second one, R rotation. In this case, we delete the element at the left subtree, so the tree becomes heavy on the right side. That's why R imbalance occurred. If it is an R imbalance, then we have to apply R rotation. To imbalance the tree, suitable rotations are applied to balance the tree. I am explaining these three cases by taking three different examples. Let's take the first example. I have an AVL tree like this and 20 is the root node here. 10 and 5 are under the left subtree and 30 is under right subtree. In the L imbalance or L rotations, we are going to delete element at the right side only. Now I want to delete 30 here. I want to delete 30. Let's see what happened. If I delete 30, the tree will become like this. How I am going to delete this 30? Based on the binary search tree property. We have already explained how to delete an element in the binary search tree. The same property is applied in the AVL tree deletion also. This is the first step in the deletion of AVL tree. And after deletion of 30, we have to check the balance factor of all the nodes present in the tree. Now let's check the balance factor. The balance factor of 5 is 0. The balance factor of 10 is 1. The balance factor of 20 is 2 minus 0, that is 2. So 2 is not acceptable in the AVL tree. That's why we have to apply rotation. I already explained, when you delete the element at the right side, the tree becomes heavy on the left side. That's why this comes under L rotation. Now in the L rotation, again we have three different cases: L1, L-1 and L0 rotation. How can you identify which kind of rotation we have to apply? For identifying this, first we have to take the node 20 as a critical node. Why I am taking 20 here? The balance factor is 2. This is not acceptable. At 20 I am getting the imbalance. That's why I am taking 20 as a critical node. The node which is immediately after 20, that is 10 here. What is the balance factor of 10 here? 1. That's why we have to apply L1 rotation. The category of this example is L1. We have to apply L1 rotation. This L1 rotation is not something new. This is imbalance type of LL in the insertion. So that is nothing but L1. But in the deletion, I am taking the balance factor of the node which is immediately after the critical node. So when we have LL imbalance, we have to apply rotation on the right side like this. Similarly, in the L1 rotation also, we have to apply a rotation right side like this. After L1 rotation, we will get the resultant tree like this. Now check the balance factor of all the nodes. The balance factor of 5 is 0. The balance factor of 20 is 0. The balance factor of 10 is 0. So this L1 rotation is simply nothing but LL rotation in the insertion of a AVL tree. Here I apply the rotation on the right side like this. How can you do this? Just 5 will comes to 10th position, 10 will comes to this position and 20 will comes to this position. This is very simple rotation. The next example 2 here. I am having a tree something like this. I want to delete a node 30. I want to delete a node 30. So now the tree becomes like this. Based on the binary search tree property, I deleted a node 30. Now check the balance factor of all the nodes. The balance factor of 15 is 0. The balance factor of 10 is -1. The balance factor of 20 is 2 now. Now I have deleted the element at the right side, so the tree becomes heavy on the left side. So this is called L imbalance. Now I want to know which type of rotations I have to apply in the L rotation. L1 or L-1 or L0. Now check, this is a critical node. 20 is a critical node. After the critical node, the immediate node is 10 here. What is the balance factor of 10? -1. So we have to apply L-1 rotation. This L-1 rotation is also not a new rotation. This is something like LR. LR rotation in the insertion of a AVL tree. In the LR rotation, this is a double rotation. So let's take here, the resultant tree is like this. In the first step, 15 will comes to this position, 10 will comes to this position, something like 20, 15 and 10. Then again 10 will comes to this position and 15 will comes to this position and 20 will comes to this position. If you want to know how we are going to apply LR rotation, you can watch my previous video on AVL insertions. Now check the balance factor of all the nodes. The balance factor of 10 is 0. The balance factor of 20 is 0. The balance factor of 15 is 0. Now the tree is balanced. Let's take another example. This is a third case. We have a tree something like this. Now I want to delete an element at the right side, that is 30. I want to delete. If I delete 30 based on the binary search tree property, now we will get a tree like this. Now check the balance factor of all the nodes. The balance factor of 5 is 0. The balance factor of 15 is 0. The balance factor of 10 is 0. The balance factor of 20 is 2. Now 2 is not acceptable and we have deleted the element at right side. Now heavy on the left side. That's why this is L type of rotation. And in L type also, which kind of rotation it is. Now check, this is a critical node 20. Here we are getting imbalance. After the node, that is 10. What is the balance factor of 10? 0. That's why apply L0 rotation. And this L0 rotation also not a new one. So here you can apply either LL rotation or you can apply LR. Here in the deletion we can say, that is, you can apply either L1 rotation or L-1 rotation. So I am applying L1 rotation. 5 will comes to this position, 10 will comes to this position, 20 will comes to this position. Now the right node of 10, that is 15, will comes to the left child of 20. This is very simple rotation. And now let's take L-1 rotation. In the L-1 rotation, this is similar to the LR rotation. First we are applying the left rotation like this. Then we have to apply right rotation like this. So after these two rotations, we will get the tree something like this. Now check the balance factor of all the nodes. The balance factor of 5 is 0. The balance factor of 20 is 0. The balance factor of 10 is 1. The balance factor of 15 is also 1. All the balance factors are acceptable after applying the L-1 rotation. Now similar to this, we have to apply R rotations. In the R rotations, we are going to delete the element at the left subtree. So the tree becomes heavy on the right side. Hence R imbalance occurred. So we have to apply either R1 rotation, R-1 rotation or R0 rotation. These rotations are also not a new one. Those are like RR rotation, RL rotation. And in the R0 rotation, you can apply either R1 rotation or R-1 rotations. These rotations I am giving you as an exercise to you. Work on it. If you have any queries, please comment in the comment section. Thank you for watching.